Hello, students. Welcome back to yet another session, and it is the last but one topic in our unit number 5, and we are going to discuss the last topic in next session. So here we are going to discuss about air distribution system and filters, air filters. So this is the content. So now we are seeing air distribution system and filters. In next session, we are going to complete air conditioning systems with controls. So temperature, pressure and humidity sensors, actuators and safety controls. So this is the only topic left out in our entire syllabus. So that we are going to discuss in next session itself. So coming to this session, air distribution systems. Air distribution systems in HVAC, heating, ventilation, and air conditioning system ensures the delivery, circulation, and return of conditioned air throughout the occupied space of a building. So here, air distribution system is responsible to circulate the conditioned air in the building. So properly designed systems optimize indoor air quality. We have seen IAQ principles and human comfort in this unit itself, and thermal comfort and energy efficiency. So objectives: the deliver the required air volume to different zones. So maintain temperature and humidity conditions, ensure proper mixing and ventilation, avoid drafts and stagnant zones. So minimize noise and energy loss. So these are the objectives of any air distribution system. So types of air distribution systems based on airflow regulation, constant air volume (CAV) system. So then supplies constant airflow at varying temperatures, simple control and economical for small buildings. So variable air volume VAV system, so that is supplies variable airflow at constant temperature, energy efficient and suitable for large buildings. So this VAV systems are very much suitable for large buildings. So dual duct systems, two ducts, hot and cold air mix at the terminal unit. So offers zonal control, but is duct heavy. So its duct is very heavy, and because it is dual ducts, two ducts are used. Multi-zone system, so one AHU, air handling unit, with multiple zones and mixing dampers, more efficient for mid-sized applications. So types of air distribution systems based on air supply and return locations. So ceiling based distribution, common in commercial buildings, diffusers placed in the false ceiling. So sidewall grill distribution used in classrooms and residences, grills fixed on sidewalls. So floor based UFAD. So here raised floor systems supply air upwards, effective in modern office buildings. So typical air distribution system, you can see in this diagram, we have diffusers, take-off valves, and air is circulated in this path where we have filter, cooling coils, heating coil, turns, and we have transitions. So this is the return registers. We have damper also, local exhaust. Air intake is through damper, and we have another damper. Damper is kept for both exhaust as well as air intake. So we have transitions through this, also exhaust takes place, and we have pre-filter, primary filter, we have fan. So this is a fan, we have cooling coils, and this is the entire layout, simple layout. So this is the diagrammatic representation of typical air distribution system. So components of air distribution system: ducts. So these are the major components. It can be rectangular or circular, made of galvanized steel or aluminum. So carry air to various locations. So diffusers, registers, terminal devices that deliver air with low velocity and uniform speed. Return grills so collect return air and send it back to AHU, air handling unit. And dampers regulate or shut off air flows in ducts. So it shuts off the airflow in ducts also. So dampers. So fans and blowers provide necessary air movement. So air can be moved with fans and blowers. So plenums are chambers that collect or distribute air. We have VAV boxes, variable air boxes. So here control air volume, that is variable air volume to individual zones. So airflow patterns, there are different mixing ventilation, high velocity supply mixes with room air, maintains uniform conditions but may distribute contaminants. So displacement ventilation, low velocity supply at floor level, extraction at ceiling. So better stratification used in clean environments. So duct design methods. So equal friction method maintains equal pressure loss per unit length, and the static region method, regain method, it recovers static pressure loss to reduce fan energy. So velocity reduction method, here, it reduces velocity progressively through the system, and design parameters supply duct velocity 4 to 10 meters per second, and return duct velocity can be 3 to 6 meters per second. Pressure drop is 1 to 2 pascals per meter. So filters in HVAC system. So filters are very important in HVAC systems. So importance is it maintains IAQ by trapping dust, pollen, bacteria, and VOCs. And we have seen all this and its impacts, causes in our IAQ principles in our earlier session in the same unit. You can recall that, and that is the importance of filters, and protect HVAC components and reduce occupant health risks. Any health hazards that can be reduced using implanting proper filters. So here these are the filters, type of filters: pre-filters, fine filters, HEPA filters, alpha filters, activated carbon filters, electrostatic filters. So these are all the types of filters, and pre-filters are used. It captures large particles greater than 10 microns in size, and fine filters, it trap smaller particles 1 to 5 microns, and HEPA filters, these are very popular filters, high efficiency particulate air filters for zero point 0.3 microns. So alpha filters, ultra low penetration air, so that is nothing but UL PA, whereas HEPA is high efficiency particulate air filters. So this is the short form, HEPA and alpha. So alpha low penetration, ultra low penetration air for 0.12 microns, even it is smaller than HEPA filters, and activated carbon filters are absorbs odors and gases, and electrostatic filters use static charge to capture dust, and for each type of filter the efficiency is given here, the 30 to 50 in case of pre-filters, and these are the types of efficiency, the various efficiency levels we can achieve in this filter types. These are the filter types. Please remember these filter types. You are going to answer the filter types only. So filter standards. So MERV rating. So it is from ASHRAE standard 52.2. So that is 1 to 16 in ASHRAE standards. So HEPA and alpha standards. So as per EN 1822, it is also standard from ISO 29463. So this is the HEPA filter. So this is the filter medium. So filter frame, and these are the filter fibers, so randomly arranged filter fibers. So diffusion lesser than 100 mm, and interception we have impact nanometers, in terms of nanometers, and aluminum separator is provided here, and this is the simple construction of HEPA filter. It is HEPA filter. So filter maintenance is also very important. It is as similar as filters are used or maintained in our automobiles. Filters plays a major role, and it cleans the fuel, air, and it supplies to engine. So in a similar way, we have to maintain filters in air conditioning and HVAC systems also. So here filter maintenance monitor differential pressure, replace clean based on pressure drop or usage through hours. Clogged filters increase fan energy and reduce air quality. So where the clogged filters normally also reduces the efficiency of the entire system. So clogged filters, so they should be replaced on at every time intervals. So that is very important in maintaining the filters. So there ends the topic here, and in next session, students, we are going to see the last topic in our uh, HVAC subject. We stop here, and these are the reference books, but it is not giving much information in these books. You can refer this material itself. This will be sufficient to face exam. So please refer this material, and you can write these points in exam, so that will be sufficient. Thank you, students. We stop here. We will meet again and discuss the last topic in our HVAC subject. Thank you, students.